Okay, so I think Blackboard Collaborate is working now. For some reason it wasn't showing the screen before, so let's just keep going here, see if this works. So we're on to some of the moments about point B. So we were looking at the moments of reactions at point D. Now we can also look at the reactions due to the force at point C. So to do that, we need to calculate the distance that C is away from point B. Or actually, no, we don't have to calculate it. We just need to write it in terms of a vector. We're going to need to calculate some stuff for some other parts of this problem, but for now, we can just write it, this part as a vector. So I'm just going to continue down here. So we see it's 2 meters in the x direction and negative 2.1 in the j direction. And that's going to be crossed with cy in the j direction. And then now we need to figure out the direction vector for point A, where Q is acting. So that's going to be, we can already see it's 0.8 in the x direction. So that's 0.8 I hat. And then 4.8 in the y direction. And then negative 2.1 in the z direction. I'm going to cross this with Q. We'll write Q as a vector. So Q as a vector is equal to 2968. And that's going to be in the I hat direction. So now we need to simplify this long equation here. So we can already see from the first part we have an I cross a J, which will give us a K. So, we have a K cross an I, which will give us J. So let's see. So yeah, we'll just start at the beginning here. So it's a negative 4.2 dx, and that's going to be in the j hat direction. And we have k cross j, which will give us a negative I, so it's going to be plus 4.2 dy in the I hat direction. Then we're going to have an I hat cross a j hat, which will give us a positive k hat here. So plus 2 cy, and that's going to be in the k hat direction. Then we have a j hat cross a j hat, which is just 0. Next, we're going to have an I cross an I, which is 0, and a j cross an I, which is negative k. So it's negative, so this is going to be a minus sign here. Okay, so we have minus 4.8 times 2968 And then I can't really fit this in here. Let's see, can I scroll down? Yeah, just gonna give myself a little more room here. So then we have K hat cross I hat, which will give us a positive J hat. But since we're multiplying by a negative number, it's going to be negative anyway. So negative 2.1 times 2968. And there's our big moment equation. Oh, I should probably write what directions these are. So we had J cross I, which was K hat. Then we had K cross I, which is J hat. Okay, so now that we have all that, we can break that down into its components. So the moment in the X, okay, so we have 4.2 dy.
I'm being slow, don't worry. Dude, my lights are so
Okay, let's see. This is, I missed a K hat here. This is supposed to be a K hat because we had an I cross a J, give us a K there. So that's the only moment in the X direction, right? Let's see. Just gonna make sure of this. Right, okay, so yeah. So if that's 0, we know that dy is also 0. Now we can look in the y direction. So here we have more. We have negative 0.2 dx minus 2.1 times 2968 is less than 0. So here we can actually solve for dx. We get dx is negative 1484, and the problem was given to us in newtons. We have the z component, so that's 2cy minus 4.8 times 2968 is 0. Okay, so this gives us cy is 7123.2. I'm just going to scroll down a little bit more. Okay, so there's all of our reactions. Or sorry, that's not all of them yet. Let's see. So we solved for dy, dx, and cy. And that should, now when we plug those into our force equations, we should be able to solve for everything. So
orientation.
So we had dx plus dx is equal to negative 2968. We solve for dx here, so that'll give us dx. Okay, so bx is equal to negative 2968 minus bx, sorry, minus dx. Which, since we solved for dx as, let's see, it's right here, negative 1484, so negative 2968. Okay, so this is just the same, negative 1484. Okay. So in total there were, let's see, there were 6 reaction forces, so here's one. Just trying to make sure we have all of them. Here's one. Here's one. Here's one. Here's one. I think we're still missing one. We're missing CY. No, we have CY. Let's see, what are we missing? We're missing BY. So we need to sum of the forces in the Y direction to get BY. Okay, so this is equal to CY, or so the opposite of CY. So there's that value there. Now we can start going into our joint equations here to solve the rest of it. Okay, so let's start with point B. Point B has 3 reactions. As well as 3 members coming off of it. So this is AB. This is BD. And this is BC. to have three reactions. BY, BX, and BZ. And if we look back, we said BZ is 0, BY is negative 7123.2, and BX is negative 1484.2. Or sorry, negative 1484. So let's just write those down. Okay, so now that we have all that written down, we need to figure out what direction AB, BD, and BC are acting in. So BD is just acting in the Z direction. AB is going to be acting in all three directions, so we'll figure that one out last. So we know that BC is going 2 meters in the X direction and 2.1 meters in the Z direction. So it turns out that it's actually let's see. A 20, 21, 29 triangle. So here's BC. This is 20, 21, 29. And then AB is going to be even more difficult because it's in three directions here. So we know it's 5.3 meters long, so I'm just going to write that. Okay. So let's start doing our sum of the forces. So the easiest one to start with is sum of the forces in the y, since only one of them is acting in the y. So let's see. So we have 4.8 over 5.3 times force AB, and then plus BY. So BY is negative 7123.2 equal to 0. So give us AB. So we just need to plug the numbers in there. So it turns out AB is 7865.2 newtons. Now we can do some of the forces. Let's see. How about some of the forces in the X? Next. This time there's only two of the numbers that are acting in the X, and we already know one of them, so that's how we know we can solve that one. So we're going to have bx plus 0.8 over 5.3 plus 2, or sorry, let's see, 20 over 29 BC is equal to 0. We know bx, we know AB, so we can then solve this for BC. So BC turns out to be -502. And now we can do some of the forces in the Z to get our last number here. So obviously BZ is 0, but we're going to have components from all three of the numbers. So this is going to be negative BD minus 20, it's supposed to be 21 over 29 times BC minus 2.1 over 5.3 times AB is equal to 0. So we can move BD to the other side and then plug in the numbers. And it turns out BD is -2752.9. So here's the three numbers we just solved for, and we have three more numbers to solve for. So we'll start doing that on the next page. So we can look at either point D or point C. Let's see. Yeah, I'm not sure if either of them would be easier to do, so I guess I'll just pick point D. So here's point D. We have this force, BD. We have force acting up, AD. And then force acting this way. So let's write these in BD, AD, and C. And then we're going to have two reactions here. This was dy and dx. So we already know BD. Let's just look back at our work, see what we got. It was negative 2752.9. Okay. So here we're solving for AD and CD. And we also know dy and dx. So let's check back, see what we're. dy is 0 right here, and dx is negative 1484. Let me just check something for a second here. Okay, so let's just start doing our sum of the forces. Again, we can start with some of the forces in the y since there's only one force acting in the y here.